All right, ladies and gentlemen, welcome back. We're going to be talking about even and odd functions now, talking about the symmetry of different functions. Okay, so first off, when we're looking for, what we're looking for here is what's the symmetry of the function, or what kind of symmetry it has. And the kind of symmetry that it has is based off whether we call the function an even function or an odd function, okay? So a function is even if for each x in the domain f of x, f of negative x is equal to f of x. Okay, so basically when I put in a negative x into my function, I get the same function back out. Okay, f of negative x equals f of x. Whereas for an odd function, when I put a negative x in, I actually get the opposite of that function. Okay, I get negative f of x. Now, not every function is even or odd. In fact, we're going to see that a lot of functions are neither. They do not have symmetry. They are not even or odd, okay? So what we're looking for are these very specific things. When you plug in a negative x, do you get the same function back out, or do you get the exact opposite of that function? And if it's neither, then you do not have any sort of symmetry, okay? So for example here, this very first one, x squared minus x to the fourth. Well, if I go ahead and I put negative x in, I'm going to have f of negative x, which will equal negative x squared minus negative x to the fourth. And again, what I'm looking for is whether my function is going to stay the same when I simplify, or whether it's going to change and be the exact opposite, okay? For this one, negative x squared minus negative x to the fourth, when I put in this negative x, when I square or take something to an even power, it's going to stay positive. So really, negative x squared is the same thing as x squared. So I can go ahead and rewrite this as x squared minus x to the fourth, which you will notice is the same equation that I started with. Okay, same equation that I started with up here. So this would in fact be an even function. I put in negative x, I got the same function back out. Okay, this one right here, I'll go ahead and put negative x into, so I'll do g of negative x, which is going to equal negative x cubed minus negative x. And what we'll notice here is that a odd power will keep it the same sign. So in this case, it's negative, so it'll stay negative. So I'm going to have negative x to the third. And then minus a negative will be plus x. All right? If you notice, this is not the same function as what we started with. However, it is the exact opposite. Every term has changed its sign. The first term was positive, now it's negative. The second term was negative, now it's positive. So this will be an odd function. Last but not least, we have this problem right here. I'm actually going to change this a little bit. We're going to put an x here. Okay, it's a little bit of a typo on this slide. So it's going to be x squared minus 4x, and we're going to go ahead and test it to see if this one is odd or even by putting in a negative x. So r of negative x will equal negative x squared minus 4 times negative x. And we'll go ahead and we'll simplify this just like we did the last one. Negative x squared is going to be x squared. And then negative 4 times negative x is going to be a positive 4. And this is where we're going to kind of see a little bit of a dilemma. Yes, the x squared stayed the same as this one. However, our 4 changed signs. It became a positive 4 x instead of a negative 4x. So we do not have the exact same function we started with, but we also don't have the exact opposite of the function that we started with. This would be an example of one that is neither. It is neither even or odd. It will not have the symmetry that we're going to see in a moment that each of these would have. Okay, so it's not even or odd, it is neither. Let's take a look at what that looks like in terms of symmetry. This is an example of an odd function, whereas the one over here is an example of an even function. And the kind of symmetry that we're talking about for each of these is basically where they're symmetrical at. For the odd function, it is symmetrical over the origin. Okay, we call it origin symmetry. And if you remember, the origin is at point 0, 0. Basically, it's almost like a rotation symmetry. If I were to spin this function around the origin, it will line up with itself and have symmetry in that way. Okay, so think of this kind of rotating around that point right here in the middle. It's going to rotate and kind of line up with itself. It has origin symmetry, whereas an even function has y-axis symmetry, meaning that I can kind of fold itself over the y-axis and it'll line up with itself. This is a little more traditional kind of symmetry that you're probably used to, right? Thinking about, okay, it's the same on either side, right? It's reflecting each other like a butterfly, right? So that's the sort of symmetry we're looking for. What you want to be careful about is a lot of people will think that the odd symmetry must be x-axis because the even is y-axis. And that's not how it works. The odd obviously is that origin, that kind of rotational symmetry. And the reasoning behind that, besides just the fact that that's how it mathematically works out, is if you think about x-axis symmetry, if you had that, you're no longer a function. You would not pass that vertical line test that we talked about before. All right, so an odd function will have that symmetry around the origin, that rotational symmetry, whereas an even function will have that y-axis symmetry, almost like a foldable symmetry where it'll fold on itself and line up, okay? So those are the different symmetries we're going to look out for. That's the odd and even functions and the origin symmetry and the y-axis symmetry that they have. Thank you all for watching.